Balancing of redox equations. Everything that we have done so far in the previous videos will play a major role to understanding the balancing of redox equation. But to me, balancing of the redox equation is the apex, is what we are dealing with from the previous videos to this point. Everything that we have done should come into play. On the board are a few of the steps involved in the balancing of redox equation. But before then, mind you, that there are other equations that you need to balance. Ordinary chemical equation, of which it plays a major role here, because that is the first thing you have to balance. When we are talking about balancing of ordinary chemical equation, invariably we are talking about adding correct number of moles, number of coefficients at the front of both the reactants and the products, so that the number of atoms at the reactant side will balance the number of atoms at the product side. That is just what it involves in balancing of ordinary chemical equation. But here, we consider two things. One, we balance number of atoms, and two, we balance number of charges. That is the only difference between balancing of redox equation and that of ordinary chemical equation. Check the step there. Number one, write down the oxidizing and the reducing agent. From the previous videos, we were able to identify, I showed you how to identify an oxidizing agent. Don't forget that oxidizing agent is an electron acceptor, while reducing agent is an electron donor. The B part of the step is write the half equations, one for oxidation and the other for reduction. And that is another thing about redox equation. We always have two half equations, and one should be for oxidation, the other is for reduction. Now, the C part of it says that we should balance the number of atoms and the charges, of which I have said it before, for each equation by adding appropriate numerical coefficient. That deals with balance of ordinary chemical equation. And the second part is balancing correct number of, or placing correct number of water, hydrogen ion, and of which hydroxide ion. On the appropriate side of the equation. Now, adding the correct number of electrons on the right hand side of the equation for oxidation and the left hand side for reduction. And make sure that the electron lost in oxidation half equation is balanced by electron gain in reduction half equation. Then you combine the two half equations. That will give you a balanced redox equation. Don't forget that electron is lost in oxidation half equation and it must be balanced by electron gain in reduction half equation. Once we consider all these things, in fact, the bone of contention here is our ability to identify an oxidizing agent and a reducing agent in a given equation. But first of all, mind you that I told you in the last video that not every equation is redox. I showed you how to identify redox equation if there are no changes in the number of species reacting and that of the product, you know that there is no redox equation. But if there are changes, for example, if this one should change from 0 to +2, if this one should change from -1 to 0, you know there are changes and it should be a redox reaction. But now we will try to find examples. For this, we may give 3 examples. Even at the starting point now, it may look a little bit lengthy. But if you just follow all these steps, we will arrive at the answer, definitely. So let's proceed to the example. Before we go to the next example, let me emphasize again that in a given set of a redox equation, identify oxidizing agent and the reducing agent. Oxidizing agents always have their oxidation number decreasing in the positive direction, while reducing agent will always have their oxidation number increasing in the positive direction. Please watch the next video for examples of balancing redox equation.